Hello everyone, I'm Yağmur Topal, and this is my EE-102 term project. I designed and implemented a smart chair system using Basis 3 FPGA board, and I called it. The goal of this project was to promote healthier sitting habits using real-time sensor feedbacks. My chair using LDR sensor in order to detect when a person is sitting and responds to comments of the user using an IR sensor. With each IR input, my chair changes its position using a servo motor. It cycles between 90-degree position, which is a default position actually at the initial step, and it is for daily stuff like working, reading, drinking coffee, and 135 degree, it is for watching film or watching television, and 180 degree, it is most commonly using for sleeping or just resting. To make these positions more intuitive, I also added LED indicators, such as in 90 degrees I'm using yellow LEDs. You can think of it as a daylight, and for 135 degree I'm using red LEDs. I got the inspiration from IMAX, they're using red light, and for the 180 degrees I don't have any light because it's sleeping or resting position. There's also 7-segment display in my project. It shows how long the user has been sitting on the chair when it's 90 degree or 135 degree position. If that time is more than 20 seconds, the buzzer starts beeping and the 7 segment shows up. And if the person stands up or goes into full recline position, buzzer stops and timing resets itself.
Initially, the chair is in the default position, which is 90 degrees. The yellow LED is on, showing the sun upright position, and the timer is off because no one is sitting. Now I will simulate sitting down by covering the LDR sensor. As you can see, the timer has started, and the display begins counting seconds. Now I will activate the IR sensor with a wave. The chair moves to 135 intermediate recline. The red LED turns on and shows the new position. Let's press it again. Now we're in the 180 full recline position. At this point, no LED is on. Let's go back to the upright or intermediate position again. Let the timer run for over 20 seconds. As soon as the timer passes 20 seconds, the display shows up and the buzzer starts beeping. This is a gentle reminder to user to either take a break or change position. Once the person stands up or chair goes to full recline, the system resets, the timer stops, the display clears, and the buzzer turns off, and it comes back to the default position, which is 90 degrees.
To sum up, this project successfully brought together sensors, servo control, timing logic, and the user feedback using VHDL on the Basis 3 FPGA board. It uses a MIDI type FSM, PWM for motor control, debouncing for accurate IR detection, and a modular structure that connects all components from LEDs and buzzer to 7-segment display. This 20-second demo timer was just for presentation purposes. In a real-world application, this could be increased to 1 or 2 hours depending on an ergonomic guidance. In the future, this project could be improved by adding wireless control, Bluetooth communication, or integration into smart home systems. Thank you for listening to me.